Hello everyone, welcome back to the YouTube channel. So I hope everyone is doing good today and of course every day as well. So today we'll be looking at an alternating current question. I have not really touched alternating current before, so let's do one today. This is from a very recent paper, 9702 variant 42. It's from 2024 and this is question 8. Okay, so without further ado, let's get started. The first one, 8A, state what is meant by the frequency of an alternating current. So this is a definition, something that you should know ideally before exam. So it's actually number of cycles per unit time. As I have always said, when it comes to definition questions, please do not lose those 1 marks or 2 marks because those marks will actually save you, because it's an easy mark. It's like a bonus mark. You just have to remember it, understand your definition and write it in exam. You get a free mark, so don't waste those marks, okay? Alright, now move on to B. An alternating current in a resistor of resistance 680 ohms varies with time according to this formula. This equation, where current is in ampere and time is in seconds. Roman 1, show that the period of the alternating current is 50 meter per second. Okay, so before we go to Roman 1, I want to talk a bit about the equation here. So this equation, if we write it in a general form, is actually I equals to I naught sine omega t. So 3.5, this 3.5 here, is actually the maximum current, or we call it the peak value of current. This is not the initial value, yeah? I naught is not the initial value, it's actually the peak value. So just let me write it here. Peak value, or some may call it the maximum value. Okay, then 40 pi is actually the omega. So this is where we will actually use omega value to find the period. So we know omega has an equation of 2 pi over t, right? So we just substitute omega with 40 pi equals to 2 pi over t. Then you do your math, you should get your period as 0.05 seconds. This is in seconds, but they want it in 50 meter per second. So of course if you convert it to, sorry, not 50 meter per second, 50 milliseconds. Oh my god, why did I say meter per second? Sorry, it's millisecond, yeah. So you want to convert it to millisecond, you need to actually divide by 10 to the power of negative 3 and you'll get 50 meter per second. Or easier way also, you can actually, skip this part. This part here you can skip. You can just straight away say equals to 50 meter per second also. No problem, it's the same. Yeah, I mean as in that 0.05 seconds, you straight away that equals to 50 meter per second. Yeah, accept this. Yep. So that's for Roman 1. Easy, right? Okay, just nice. Now we need to sketch your graph. So sketching your graph is very important because you need to make sure you got your curve right, you got your points right, and your period. So usually when they ask period, definitely got graph lah, right? So they ask to sketch a variation of current with time between time equals to 0 and equals to 100 meter millisecond. Why am I keep saying meter per second? Milliseconds. Yeah, it's millisecond. Okay. So we know the period is 50 milliseconds. So that means we got to draw 2 cycles because they want it up to 100. Okay. So we know the period. Now next thing to know is our peak values or maximum values, which in this case we have found out just now, which is 3.5. So you go to your graph, find for 3.5. Make sure it's an accurate point of 3.5. So this is 3. So this is 0, 1, 2, 3, 4, 5. So 5 is somewhere here. So if I were to draw a line between that will be my 3.5. Yep. So of course you need the negative side as well. So this is 3. This is negative 3.5. I'm drawing a line so that it's easy for me to draw the graph. Yep. Okay. And 50 millisecond is 1 cycle. And they want up to 100 millisecond. That means there's 2 cycles. Okay. Now let's draw. And this is a sine graph. So make sure you draw a sinusoidal graph. A sine graph starting at 0, 0. So let's get started. So this, make sure it's curved, yeah. Okay, make sure you curve something like this. I'm trying my very best to draw nicely, so please do not judge my drawing. As long as you get the idea. Oops, it's very... Okay, that doesn't look nice at all. I should consider taking up art class, just to draw graphs. Because this is 3 marks, so you gotta draw. Okay, that's... Okay, then I'm gonna draw. Okay, that is not a curve. You need to make sure your point up there looks like... Okay, I'm gonna stop there and draw the blue part. I know y'all can draw better than me, so please kindly draw better than me. I'm not that good at it, but I am trying my best. Okay, something like that, almost there. Okay, so what are the main things to be aware of? Starting at 0, 0, okay, then make sure your peak is at 3.5, positive 3.5 amperes and negative 3.5 amperes. The next thing is, make sure there is 2 cycles with period 50 millisecond, 50 millisecond, and another cycle at 100 millisecond. Okay, so that's the thing you should be aware of. Yep, so this is roughly how your graph would look like, and you get your 3 marks. Okay, moving on. B Roman 3. Determine the root mean square current in the resistor. So root mean square has a formula which is equals to I0 over cert2. So we know our I0 is 3.5. So 3.5 divided by cert2. And you will get, okay, let me get my calculator. 2.475. To two significant figure, it's 2.5. So if you're wondering why I wrote 2.475 first, then only write 2.5 ampere, it's because if you need to use these values in the next question, or they ask you to use it, it's better to use the one with 3 decimal places or 4 decimal places, so that your answer is more accurate. If you use the one with 2 significant figure, you might not get an accurate answer. So it's best to have a habit of writing 3 decimal places first, then you write your answer simplified to 2 significant figure. Yeah, it's a good habit to implement actually. So moving on to C. Use data from B, including your answer in B Roman 3. There you go. They ask you to use your answer. To show by calculation that the mean power in the 680 ohm resistor is half of the peak power. Okay. So we know that to find mean power, it is the current, the root mean square current, multiplied by your resistance. So you'll get 2.475, because I'm using the 3 decimal place value, 475 multiplied by your resistance, 680. And let's see, what do we get? Don't forget to... Oh wait, thank God. I was about to say don't forget to square, and I did not square it myself. Yes, don't forget to square. There's a square, right? It's I square R, because this formula came from the general equation of P equals to I square R, right? So yes, you would make sure to square it. So you would get 4165. Yep. Okay. Now, what is your peak power? Your peak power is the maximum power. Yep, it's the maximum power. And for you to get the maximum power, you need to get the maximum value of current, I square R. I naught square R. So your I naught just now was 3.5 square. Your resistance is 680. And you should get 8330. And to show that it's half, when you can write it actually like this. The mean power is actually half of 8330. When you take half of 8330, you would actually get 4165. So they ask, show by calculation that the mean power in the 680 ohm resistor is half of the peak power, which is true. Half of the maximum power, half of the peak power, you get 4165. You get back your mean power. So you have actually finally shown your answer. Yeah. Okay. And you get your 3 marks. That's actually the end of the question. But you know I don't pick questions for fun, right? There must be a reason why I picked this question. Okay. Now, the question is, why is it half? Like, why does it has to be that the mean power in the resistor is actually equals to half of the maximum power? Why is it not quarter, or why is it not 1/3? Why does it have to be half? Okay, so we know that this is our general equation when it comes to power. P equals to I square R. So from this, resistance is constant, 680 ohm throughout. So we can safely say that power is directly proportional to I square. So any changes made to I square graph, the same changes applies to the power as well. So from this question, the equation used was sine, right? So I'm going to use that sine equation. I naught sine omega t, right? So now if you square this equation, you will get I naught square sine square omega t. So now you would get a sine square graph. So let me draw for you. Okay, I draw a sine graph first, an example of sine graph. This is I and this is your t. The sine graph will look something like this. Yeah, something like that, right? Now what if it's sine square? I think I should draw this a bit lower. Okay. It's gonna look something like this. Yeah, I'm not drawing the entire one. I'm just giving you an idea how an I square graph against t looks like. So what would be the average of this graph? It will be half. Now that is the question I ask you. Why is it half? So we all know that it has to be half. It has to be half. But why is it half? Okay, so this is where you need to use a bit of integration. So let's go back to the basic knowledge of statistical mean. So we know mean means you plus all the values divided by a number of values. So example, you have 5, 6, 7, 8, 13, then 99. So to know the mean of this value, you plus everything divided by 6. because there's 1, 2, 3, 4, 5, 6 values, right? So sum of all the values divided by number of values. That is for discrete data. Now what if you have continuous data like the sine graph? What do you have to do? So continuous data, you want to find the sum is when you use integral. So if I were to find the mean of this graph, what I should do is I should take, let me say mean power. Also, I forgot to add, since this is a sine graph, this is 1, this is -1, and this would be 1. Okay, alright, so now coming back. So since this is a continuous data, we need to use integral. If it's a discrete data, you can just sum it up divided by the value. So since this is continuous, we're going to use integration. So how would it look like? It will be 1 over 2 pi. You integrate from 0 to 2 pi, the one whole cycle. You check for one whole cycle. F theta. So what is my F theta? So I'm going to name my F theta as sine square theta equals to 1 minus cos 2 theta over 2. So before you panic or anything, where did I get this equation? Don't worry, I'll show you where I get that equation. So in that case, I'll erase this first since it's not really relevant. So I'll push this graph up to show you where I get that. Okay, so we know that there's a trigo identity for a double angle. Cos 2 theta equals to cos square theta minus sine square theta. Am I right? Okay, and you also know that cos square theta plus sine square theta equals to 1. So now I want to make cos square theta as my subject. I get 1 minus sine square theta. So if I sub this inside here, I will get cos 2 theta equals to 1 minus sine square theta minus sine square theta, and I would get 1 minus 2 sine square theta. So making sine square theta as the subject, I would get 1 minus cos 2 theta over 2. Why am I taking sine square theta? Why not cos square theta? You can take cos square theta depending on your graph. In this question, they use sine. So I'm going to stick to using sine. So like I said, when you square your current, you're going to get I naught square sine square. So this is actually a sine square graph. Because you square your sine graph, you're going to get this graph. And power is directly proportional to your I square. So which also means directly proportional to your sine square graph. So therefore, we are going to use this one to find the mean value of this graph. Because the function of this graph is actually sine squared. So to find the mean value of this function, you must take the integration of it, because this is a continuous data. Okay. I will add a new page down here. Okay. Now, we are going to solve this part here. So, you might have another question. Why is there 1 over 2 pi outside? Okay. So, when it comes to discrete data, what do is we take the sum of all the values divided by the number of values, right? But when it comes to continuous data, what do is we divide it by the length of the interval. So length of one complete cycle is 2 pi. To make it easy, we just look at one complete cycle first to actually simplify our calculation. That's why I'm talking in terms of one complete cycle. So one complete cycle for sine graph gives you 2 pi. Right? So that is why after you sum the values, you divide it by 2 pi. So in other words, the number of values in a normal mean for discrete data corresponds to the interval length for continuous data, which is 2 pi. Okay, so now let's start deriving this. Oops. Mean power equals to 1 over 2 pi 0 to 2 pi 1 minus cos 2 theta over 2. Or I think I should write like this first. Sine square theta equals to 1 over 2 pi 2 pi 0 1 minus cos 2 theta over 2. Yeah, this is even better to understand, right? Yeah. So now let's integrate. So you need to use a little bit of your integration knowledge here. So 1 over 2 pi, I'm going to take out the 2. So 2 pi, I'm going to separate this into 2 different integration parts. d theta minus cos 2 theta. Oops, I forgot my d theta. Okay. We get 1 over 4 pi theta 2 pi 0 minus 1 over 2 sine 2 theta 2 pi 0. You get 1 over 4 pi 2 pi minus 0 because sine 4 pi is 0. When you sub in 2 pi here, sine 4 pi gives you 0 because sine 2 pi is 0, so therefore 4 pi, the second cycle will also be 0. So that's 0. So when you simplify this, you'll get 1 over 2. So the mean power is actually half. So since we are using a sine graph, our maximum value is 1. So 1 over 2 times 1, you're supposed to get 1. So that is why the mean power value here is 1. So in other words, this is actually 1 over 2 of the maximum power. So that is why your mean value can also be written as half of the maximum power or half of the peak power. It's this. Yep. So this part is not required in exam, like you don't really have to know it for exam base, but it's good to know where you get half. It's good to know because you get to understand better where you get half, because I had the question of why is it half and not other value, and there you go, you get an answer. So if you're curious about it, I hope this video answers your question. So before we end to this video, let's go review back one by one and understand from where we started to see where have we gotten. Okay, so we started with this general equation, P equals to I square R. Then since resistance is constant, so power is directly proportional to I square. So if let's say the mean value for current is half, for I square graph is half, then the mean value for power should also be half as well. But half of what? If let's say this graph, the mean value is half of the maximum current, then it should be half of the maximum power as well to get your mean power, because they are directly proportional. So in other words, any changes that happens to current, anything that happens in the current graph, it is the same for your power graph as well. Okay. Anyways, we had this equation, general equation, I equals to I naught sine omega t. Why did I use cos? You can use cos, just that in this question they use sine, so I just straight away use sine. You can use cos, you will get a similar answer. If the question use cos, of course, yeah. So I square would be I naught square sine square omega t. So this is actually your sine square graph. So we know that it has to be half. And probably someone told you, oh, you take half of the maximum value in the sine graph, you get in the sine square graph, you get the average value. But why is it half? That's my question to you, and that is what we're trying to find out. So what did we do is we tried to find it using integration, because this graph is a continuous data. It has infinite number of values. So that is why we need to do integration. If this was a discrete data, what you would have done, you take all the values, sum and divide it by number of values. That is discrete data. But since this is a continuous data, you have to do integration. So to make the calculation simple, I'm going to take into consideration of one cycle. So I'll take 0 to 2 pi, one complete cycle. Okay. Then what is this f theta? This is your function. Basically, I find my sine square function. So what I did is I started with a double angle, and this is a very famous identity. Make cos square subject, sub in, and you'll get this. So I get an equation for my sine square theta. Then what I did was I sub back into this equation, 1 minus cos 2 theta divided by 2. Then you do your integration, you will come to a final answer of 1 over 2. So what does this 1 over 2 mean? It is actually 1 over 2 of the maximum value of current. Since the maximum value is 1 here, because it's a sine graph, so they simplify it to 1 over 2. So actually, I think right, this part here, I should just write mean current. It's not mean power yet, because we are calculating it from the current graph, right? So yes, it's mean current. And since their power and is directly proportional to I square, to the current square graph, therefore, if the mean current is half of the maximum current, therefore the mean power is half of the maximum power as well. That is why it's half. Yep. So if you're wondering why did I use double angle to come up with oopsie, to come up with this particular equation, I could have just take 1 minus cos square theta from this and integrate, right? So integrating double angle is more easier than a cos squared function. So that is why I resorted to double angle. Yeah. So this part is just for your understanding. Totally is just for understanding why is it half. Not really require an exam. It's this part that you have to be. Make sure this part. Yeah, make sure you do this in exam and you'll get your 3 marks. So that is all for today's video. I hope you learned something new and you understand better about alternating current. And I'll see you in the next one. Please take care of yourself and bye bye. Stay hydrated as well. Have a nice day ahead. Bye bye.